Here's the last of 3 videos. Let's look at the situation. A kindergarten classroom has 12 girls and 8 boys. This was actually the case in Odette's class when she was in kindergarten. Each day the teacher selects one student to be child of the day. Suppose that the teacher randomly selects a student each day. All right, so we're going to be looking at 3 situations here. You need to keep in mind that there are 12 girls and that there are 8 boys. Boys does not have a D in it. Okay. So in this column, let's assume that a student can be chosen again. And in this column, let's assume that a student cannot be chosen for a second time. Or in other words, this one is with replacement, and this one is without replacement. And let's recall that when they're with replacement, that means that these events will be independent. And here, without replacement, these events will be dependent. So what is the probability that the first 3 students selected are girls? So we want girl, girl, girl. In this case, because they can be replaced, we know that on the first day, there are 12 girls we could choose from, and that's out of 20 students in class. And we know that on the second day, that probability is not going to change because we could still choose the same kid again. And then on the third day, that probability will be identical. So we get 12 over 20 multiplied 3 times, which is going to give us 21.6%. However, if we move over here to without replacement, on the first day we want a girl. And there's 12 of them to choose from the 20 kids in class. But on the second day, when we want a girl again, suddenly the situation has changed. We've already chosen a girl here, so there are only 11 girls left to choose from, and there are only 19 students left to choose from. Likewise, on the third day, now there are only 10 girls left and 18 students to choose from. So if you multiply that out, you're actually going to get a slightly smaller number. Under the without replacement, there's only a 19.3% chance that we get 3 girls in a row. Let's look at a slightly different example. In B, it says, what is the probability that the first boy is not selected until the third day? So if the first boy is not chosen until the third day, that means we want a girl, and then a girl, and then a boy. Now with replacement, that would be 12 out of 20, and then 12 out of 20, and then on the third day, there are 8 boys out of the 20 to choose from. And that percentage is a little more than 14%. Without replacement, however, if we don't want a boy until the third day, and we need a girl here and a girl here, there would be 12 out of the 20 students are girls on the first day. There are 11 girls left out of 19 students on the second day. And then on the third day, there are only 18 students left. How many of them are boys? 8, because we haven't chosen a boy yet. Therefore, our answer is going to end up being, it's actually slightly higher than when we play the game with replacement. Last one says, what is the probability that there is at least one boy in the first week? So I'm assuming that a week means 5 days of school. And we also know that anytime we're asked an at least, it means we want to do 1 minus the probability of none. So here with replacement, if there are no boys chosen, that means it's 1 minus girl, 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 girl. So that's 12 out of 20, 12 out of 20, 12 out of 20, 12 out of 20, and 12 out of 20. When you put that in your calculator, you end up with this number. So pretty good chance that a boy gets chosen in the first week. Now let's do this using the without replacement method. So at least one boy would be 1 minus no boys, which means all girls. And it would go like this. 12 out of 20 are girls, 11 out of the 19 left are girls, 10 out of the 18 left are girls. See how both the numerator and the denominator are going to drop by 1 each time. 9 out of 17, and then 8 out of 16, which comes out to 9. Well, there you have it. There's independence and dependence. That concludes lesson 33. You can go do assignment number 33 now.